Yes, come, let's define the unit of current. So we know that unit of current is equal to unit of charge divided by unit of time. So now we are going to define the unit of current. So we have I is equal to Q by T. Now we are defining the unit of current. So unit of current is equal to unit of charge divided by unit of time. Correct? So we'll define this one. So unit of current is ampere. So otherwise we can write unit of current is equal to I is equal to unit of charge. Correct? So unit of charge is coulomb and unit of time is second. We can say SI unit of charge is coulomb, 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 and your SI unit of time is second, and unit of current is ampere. So current is equal to, we can write the SI unit coulomb per second. This is the derived unit, or generally you can write the ampere. SI unit of current is, we have coulomb per second is known as ampere. So SI unit of current is coulomb per second, where this coulomb per second is known as ampere. So this is the SI unit. SI unit of charge, SI unit of time, and unit of current. So now we'll define what is the ampere. So now we have the SI units, correct? So SI units, SI unit of current is ampere. 1 ampere is equal to SI unit of charge is coulomb. Let's take 1 coulomb, and time is 1 second. Now we'll define ampere, 1 ampere. So the current is 1 ampere when, if the rate of flow of 1 coulomb of charge per second. The current is 1 ampere when the rate of flow of 1 coulomb of charge per second, means in 1 second there must be a flow of 1 coulomb of charge. Okay. So now, okay, we have 1 coulomb of charge in 1 second. There is a flow of 1 coulomb of charge in 1 second. Now let's find out, in 1 coulomb how many electrons are there. So we know the formula, Q is equal to N into E, where N is the number of electrons, E is the charge of electron, and Q, we know 1 coulomb of charge. Let's find out in 1 coulomb of charge how many electrons are there. In 1 coulomb of charge, how many electrons are there? To find out that, so we know where number of electrons is equal to 1 divided by Q by E. 1 coulomb of charge, that is 1.6 into 10 power minus 19. If you divide, in 1 coulomb of charge how many electrons are there, we can find out. Okay na? So how to divide? You can, with this Cbse, you can simply do it. Okay. So I will explain the method also. If you take 1 by 1.6, you will get something 0.625 something. Okay. So now let's calculate this. So here I have a decimal point. So after 1 digit, I have a decimal point. So when we have the decimal point after 1 digit, so multiply that with 10. So let's multiply the numerator and the denominator by 10. So 1 into 10 by 1.6 into 10 power minus 90 into 10. Because after one digit I have a decimal point, so that's why I multiplied by 10. So then I will get 10 into, let's shift this 10 power minus 19 to numerator. I will get 10 power plus 90 divided by 16. 1.6 into 10, we get 16. So if you divide 10 by 16, correct, no? So you will get the number. So 10 by 16, you will get n is equal to 0.625 into 10 power 90. Correct? So this is the number you are getting. Now let's make it to 10 power. Let's convert this 10 power 80. So to make it 10 power 18, you must shift the decimal point towards right. So when the decimal point is shifted towards right, it is negatively raised. When the decimal point is shifted towards right, it is negatively raised. So here I am shifting from point here to here, then it is minus 1. If I shift to here, that is minus 2. If I shift to here, minus 3, like that. If you shift the decimal point, it is negatively raised. Okay. So I will explain this, how to raise the decimal point, how to write the any given number in 10 powers. I will explain with it. I will take the another class. I will explain in detail in a new video. So now let's shift this decimal point here, then I'll get 6.25. The decimal point from here to here, it is coming, so it is 10 power minus 1. So 19 into 10 power minus 1. So we get 6.25 into 10 power 18 electrons. So in 1 coulomb of charge, there are 6.25 into 10 power 18 electrons are there. So if you take this number of electrons and if we define the unit of current, how we can define? So here we define that 1 ampere is 1 coulomb of charge, rate of flow of 1 coulomb of charge. That is in 1 second. So 1 coulomb means it is carrying the, so when 6.25 into 10 power 18 electrons passes the conductor in 1 second, we can define like that also. 1 ampere means 6.25 into 10 power 18 electrons passes the cross section of the conductor in 1 second. So that is the meaning of this with respect to the number of electrons. Okay now, so this is how we can define the unit of current. So unit of current, we know 1 ampere is equal to 1 coulomb by 1 second. In the examination they will ask, define the unit of current. Unit of current is ampere. How to define? Ampere is nothing but rate of flow of 1 coulomb of charge in 1 second. Flow of 1 coulomb of charge in 1 second. Correct? So that is the definition of unit of current. When 1 coulomb of charge passes across the conductor, passes through the cross section of the conductor in 1 second, is known as an ampere. 1 ampere means 1 ampere current flowing through cross section of the conductor means 6.25 into 10 power 18 electrons. So they are passing the cross section of the conductor in 1 second. So this is the SI unit of current. So SI unit of current is coulomb per second. Coulomb per second is known as ampere. How we got the coulomb per second? So that is SI unit of charge is coulomb. SI unit of time is second. So we got coulomb per second. You can write that as like this, coulomb per second also. So in the numerator we have coulomb, divided by second. When the second goes to the numerator, from denominator to numerator, so second to the power of minus 1. Okay, so that this is capital C, keep in mind. Coulomb, scientist name, capital C. So this is the definition of unit of current and calculation of number of electrons in 1 coulomb. Keep in mind, in 1 coulomb of charge, there are 6.25 into 10 power 18 electrons are there. So now, let's suppose if we have a weak currents. How the weak currents are measured? So weak currents are measured in milliamperes. Milli means 10 power minus 3. And microamperes. Microamperes. So that is 10 power minus 6. When we have a weak current, so that weak currents are measured in milliamperes. That is, milli means 10 power minus 3 and microamperes. So that is in 10 power minus 6. So that one we have. Okay. Yes, this is what we have: electric current and SI unit of current and the charge. And let's define the charge. What is a charge? So we know that charge Q is equal to N into E, number of electrons, into charge of electron. What is the definition of the charge? I'll define this. Okay. So definition of the charge. Charge is an intrinsic property of matter. Charge is an intrinsic property of matter. Intrinsic property of matter, by virtue which exhibit electromagnetic force. So these charges exhibit the electromagnetic force. This is the intrinsic property of matter. So we know that we have two types of charges, plus and minus. Correct? So when we have a like charges repel each other, when we have unlike charges attract each other, there will be electromagnetic force. So all the matter contains the charges. So that is the intrinsic property of the matter which exhibit the electromagnetic force. Like charges repels each other, unlike charges attract each other. So that is the intrinsic property of the charge. So charge is an intrinsic property of matter which exhibit electromagnetic force. So that is the charge. We have two types of charge. Correct? So discovered by Benjamin Franklin. Positive and negative. Yes. So this is about the current and the SI unit of current, and about the charge and the number of electrons present in 1 coulomb of charge. Current, very simple definition, rate of flow of charges. Correct? So across the conductor, when 1 coulomb of charge passes in 1 second, that we can define it as a unit of current. Correct? So current is nothing but rate of flow of charge across the cross section of the conductor is current. Okay, now that is, and the relation we have, I is equal to Q by T. Then we had defined the unit of current. Then we have the SI unit, coulomb per second or ampere. Coulomb per second is known as ampere. And we have calculated the number of electrons in 1 coulomb of charge. Okay, now. So this is what we have. In the next video, we'll see the direction of the current, conventional direction of the current. Okay, na? So we'll understand that. So now you read all these concepts, and if you have any doubt, please ask me in the comment section. Thank you.